Today we're going to continue on with chapter 1. We're going to cover section 2, and we're going to learn about measuring and constructing segments. Now, like I told you before at the beginning, I'm not going to be grading you on your construction ability. So again, we're not going to be getting out rulers or compasses or protractors to measure things or specifically draw things. So again, any kind of construction that you'll need to do would be for your own benefit, to give yourself a little visual. So the first thing we're going to learn about is using a number line. And a coordinate is a number that corresponds to a point. So on my number line here, the number -2 is the coordinate of A, or the number 2 would be the coordinate of D. So a coordinate is the number that's going to correspond to a letter or to a point. Now, we're going to be finding the distance of between two coordinates on our number line. Now, if they give you a visual like this, we could really just count the little spaces. However, if they just give you the information, and let's say without a picture, and they say find the length of AD, and then they tell you the coordinate of A is -2 and the coordinate of D is +2, then what we're going to do is we're going to subtract. We're finding the difference, and the word difference means to subtract, of the coordinates. And then after we find that distance or that difference, we're going to absolute value that answer. So the whole purpose of finding an absolute value of a number is it doesn't matter the order that you subtract. So for example, we can either decide I'm going to take A's coordinate and subtract D's coordinate, or vice versa. So for example, if I did it DA or AD, the numbers that I subtract would go in here differently. So if I did DA, that would have been 2, and difference is subtraction, minus -2. I put absolute value around it. But if I did AD, it would have been -2 minus 2. It's still got absolute value bars around it. So just to show you, as long as you absolute value your answer, it's going to be the same either way. Now, this is where your rules of adding and subtracting integers comes into play. Your middle school teacher in your pre-algebra course should have taught you how to add and subtract integers. They might have taught you keep, change, flip, stay, change, whatever way that you know to subtract integers, that's what you're going to use. So I like to do keep, change, flip, keep it, change it to addition, flip it to the opposite sign. 2 plus 2 is 4. The absolute value of 4 is 4. And then here, if I keep, flip, change this, I'm really adding -2 plus -2, which is -4, but then I need to absolute value it. So whenever you find the absolute value of a number, really what you're doing is finding the distance that number is from 0. And it just makes it positive. What you're going to learn is distance is never negative. Now, if you don't want to have to remember the absolute value in the end, what you can always remember to do is always subtract the bigger coordinate from the smaller coordinate. So here, if I just would have done it this way, notice I wouldn't have really needed to absolute value it. But just remember, whatever order you subtract them, just remember, make it positive in the end. You're finding the absolute value. Now again, if they give you a visual, like I did up here, another way to find the distance between point A, or coordinate A, and coordinate D here, all we would have had to do is count the little gaps. So 1, 2, 3, 4 gaps in between -2 and +2. So the distance there is going to be +4. So if you have the number line, you can also just count. But if you don't have a visual, then do the subtraction. We're going to learn our very first postulate. Now, a postulate is a statement that's accepted without proof. It could be, you could also think of it as a rule. So it's just a rule that you follow and you don't need to prove it. Just like a definition. Now, we're also going to be talking about theorems in this course, and that's going to be coming up in another section. But a theorem is a rule that can be proven. Postulates, you don't need to prove them. You just follow the rule and that's it. Now, when we're learning these postulates and these theorems, they're going to be numbered. You don't need to memorize that the ruler postulate is postulate number 1. All I want you to do whenever we learn any postulates or theorems is that you just remember what they say. Some of them will have names like this one. The reason why I'm not having you memorize the numbers is because when you take the SAT or the PSAT, they're not going to give you a question on the SAT that says, pick which multiple choice answer restates postulate 1, because every textbook numbers their theorems and postulates differently. The way that our textbook does it is that the very first postulate you come to in the textbook is called postulate number 1. The next one that we're going to encounter will be postulate 2, and so on. So every textbook could be written differently. Another textbook might not introduce the ruler postulate maybe until later on in the chapter, and it may not be the first postulate that is taught to you. So you don't need to memorize the numbers. I will never ask you restate postulate 1 or restate postulate 10. Just know what they state. If I give you a question and I say, explain to me the ruler postulate, you should be able to do that. So what the ruler postulate states is that the points on a line can be matched 1-to-1 with real numbers. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. So this bullet point right here is what we just did on the previous slide. So you can either subtract the coordinates and then absolute value that difference, or if you already have a number line pictured, count the spaces. So let me just go ahead and show you another example just to demonstrate. So if I add a number line here to my slide, and again, when you set up the number line, the negative numbers are to the left. 0 is in the middle of the positive and negatives. This could be B, and then positive 1, C, and then 2, and then 3. And then let's say they asked you to find what is the distance from E to A. So again, you could count the spaces, 1, 2, 3, 4, or subtract. And if you do big minus small, you would do 3 minus -1. We could still show the absolute value, but this answer becomes positive. And then 3 plus 1 is 4. Absolute value of 4 is 4. Now again, if you did it the other way and did -1 minus 3, you still get the same answer. The distance will always be positive. Distance is never negative. So next we're going to talk about a construction. So a construction is a geometric drawing that's going to use a limited set of tools. And generally what you're going to be using, and if you were to make a construction, would be a compass or a straight edge. We are not going to pull out compasses and straight edges or rulers to draw these geometric figures. Again, you can just draw them by hand. And again, I'm not going to grade you on a construction. So if you ever saw a question on an SAT and they said, what would be a tool that you would use to draw a line segment? And you could say a ruler or a straight edge. You would use a compass when you want to draw circles or even angles. Next, we're going to define the word congruent. And congruent is more or less the same thing as saying that they're equal. However, we're talking figures here, not numbers. The symbol for congruent is an equal sign with a little wave on top. This is the symbol for congruent. So when we state that two objects are congruent, they're going to have exactly the same size and shape. When we refer to two congruent line segments, those are going to be segments that have the same length. So for example, if I were to draw two segments here, and if I call this one segment AB, and then if I draw another segment, and if I call this CD, now just looking at these, in geometry, you can never assume anything. The only thing you can ever assume is when you have a straight line. If you have something that looks like a right angle, a 90 degrees, unless they tell you it's a right angle or they tell you the measurement, you can't assume that it's right. So in this case, looking at this, I cannot assume that these two segments are congruent. I have no idea how long AB is, and I have no idea how long CD is. If I was asked to prove that these two segments are congruent, I would either need to be given the measurement of the segments. So let's say I told you that segment AB had a length of 4 and CD also had a length of 4. Then I could state that AB is congruent to CD. Another way that I could tell that two segments are congruent is they're going to be using congruency marks or tick marks. And a congruency mark on a segment usually looks like a little dash. So if I had like a little dash through this one with one mark, and if I had one mark here, that would be another way that I could tell that the two segments are congruent without even knowing how long they are. I would look for congruency marks. This statement right here is read, AB is congruent to CD. That's how you would read this statement. Right now, in this chapter, we're only talking about congruent segments. We'll get into angles as well, but later on, we'll start talking about congruent triangles, congruent rectangles, any type of quadrilateral, congruent circles. We'll go through all the shapes, and we'll look to see, do those shapes have exactly the same shape and size? So our second postulate is called the segment addition postulate. Again, you don't need to memorize that it's called postulate number 2. Memorize the name and what it says. So the segment addition postulate states that if point B is between A and C, then AB plus BC equals AC. And then you can say in reverse of that, if AB plus BC equals AC, then we know that B is between A and C. Now, this word here, between, it doesn't mean that B is right smack in the middle. It's just somewhere in between A and C. And I'm going to give you a visual. I'm going to show you what I mean. I'm going to draw a segment. So let's say I put a point here, and a point here, and then I'm going to put B in between. So A, B, C. Notice I did not place it in the middle. It could have been, but it doesn't need to be. And I'm going to tell you that the length between A and B is 2. And the length between B and C, I'm going to say that that is 6. So what if I asked you to find the length of AC? So if you notice up here, what the segment addition postulate tells us is that we can take this little piece, this little segment, and add it to this other segment, and it will give us the entire length of AC. So what we'll do is we're going to do AB plus BC equals the whole thing. So I can add 2 plus 6, and that will give me the length of the entire segment AC. So this tells me that the length of AC is equal to 8. This is using our segment addition postulate by adding smaller segments to get the total piece. Now, they may also ask you to work backwards. So let me draw another segment here. And again, I'll call it A. Let me put B in the middle. So B, and then C. And let's say I told you that the length of AB is 1. And I'm going to give you the total length. And I want you to find how big BC is. So again, I'm going to do the same thing. This is where our Algebra 1 skills are going to come into play. AB plus BC equals AC. Now what I'm going to do is I'm going to state that BC, I'm going to call this X. AB is 1. And then I'm going to set it equal to the whole length, which is AC. And now I have to solve this algebraic equation by using my subtraction property of equality. So what I need to do is subtract 1 from both sides, and I get X equals 4. And X was the length of BC, so BC equals 4. Now, when you name a segment, you can name it with just the capital letters without the picture on top. So be aware that if you just see 2 letters without the bar on top, they're referring to a segment. So it'll either be like I showed you over here on the left with the bars on top, or it could also be written with the 2 capital letters. Both ways are used to name segments. We'll be using this postulate in our proofs. So we're going to be, when we get to the proof part, we will be writing 2-column proofs where you're going to give a statement in the left column, and then you're going to give a reason in the right column. And the reason is going to be definitions, theorems, and postulates. So sometimes what I like to do is abbreviate this postulate. And sometimes instead of having to write out segment addition postulate in my proof, I abbreviate this as SAP. It's totally up to you if you want to abbreviate it. I just took the first letter of segment, first letter of addition, and the first letter of postulate, and I call this SAP. This is my segment addition postulate. Now we're going to do some examples of the notes that we just took. Now, in this first example, they're expecting us to find the distance or the length between two coordinates. Now, you need to remember how to graph ordered pairs. When you're doing the homework tonight, if you have any questions where they're going to ask you to plot points, find a picture of a coordinate plane and insert that into your homework. So anytime you're asked to graph ordered pairs, look for a coordinate plane, whether you find a picture somewhere and screenshot it and save it as a favorite. Just have it somewhere in Notability saved or in your photos. You can also put in graph paper. There's a tool on Notability where you can add a picture of graph paper, crop it, and make your own coordinate plane. It's totally up to you. So let's practice graphing ordered pairs. Remember, when you have a coordinate, the first number is the X, the second is the Y. When you're graphing, X tells you which way you move left or right, and the Y tells you up or down. So when I go to plot ordered pair J, I'm going to go over to the left to -3, and then up to the Y coordinate of 4. So -3, +4 would be up here. And this would be J, and I'm going to label it. Then I'm going to label K. And K will be the order pair 2, 4, over to the right to 2, and then up to 4. Connect the points, and it wants to know, is JK congruent to LM? So now, I can either choose, since I just graphed it, I could count the little boxes, the little squares, and notice it has 1, 2, 3, 4, 5 squares. So the length of JK is 5. Now, if you didn't want to count the squares, what you're going to do is take the coordinates, and you're going to look to see which coordinate is the same, the X or the Y. And we don't use that one. And then if we wanted to do the difference of the coordinates and then absolute value it, we could. So JK would be 2 minus -3, absolute value it. So keep, change, flip this. 2 plus 3 is 5. Absolute value of 5 is 5. So same answer I got when I counted the little squares. Now let's plot LM. L is 1, 3. Go to the right to 1, and then up to 3. For M, I'm going to go to the right to 1, and then down to -2. Connect my points. Again, I could count the boxes. 1, 2, 3, 4, 5. I can state that LM equals 5. So just by counting the squares, I can state that JK is congruent to LM. But if I didn't have a coordinate plane given to me, then I would have to subtract. So if I subtracted their coordinates, and again, L was 1, 3, and M was 1, -2, again, get rid of the one that is the same, and now subtract. 3 minus -2, keep, change, flip it, and 3 plus 2 is 5. Absolute value of 5 is 5. So you can get the distance or the length of that segment either by subtracting, finding the difference, and then absolute valuing it, or if you've got the coordinate plane and you've graphed them, count the little boxes. Okay, so we're going to do some sometimes, always, or nevers. So number 1, the length of a segment is sometimes, always, or never negative. Never. Beautiful. Because the length will never be a negative number. It's always positive. Number 2, if point S is between R and V, then S sometimes, good, always lies on RV. Perfect. And if you don't want to write in the word, you could put at capital S for sometimes, capital A for always, and capital N for never, if it's hard to squeeze in those words on that little blank. And then the last one, a coordinate can sometimes, always, or never be paired with a point on a number line. Always. It's the ruler postulate. This one's always. And the reason why we know that is that first postulate, the ruler postulate. One more example. This time we're not plotting ordered pairs. We're using our algebra skills. We're going to be setting up equations to solve. We'll be combining like terms and then solving for x, and then we'll plug it back in to get the lengths of the segments. Okay, so example 3. It says J is between I and K. So I'm going to notice there's no picture. So I'm going to draw myself a picture. I'm going to draw the segment. I have I and K, and I'm going to put J somewhere in between. Doesn't have to be in the middle. And then I'm also going to label what they gave to me. So they told me that IJ is 2x. JK is 4x minus 6. And they gave me the length of the whole thing. IK is 30. So what I'm going to be using here is my segment addition postulate. Before, when we did this in the notes, they were numbers. But now we're going to use our algebra skills. So I'm going to be showing you that IJ plus JK equals IK. And I'm going to replace what was given to me. IJ is 2x, JK 4x minus 6, and lastly, IK is 30. Use my Algebra 1 skills. I'm going to combine my like terms. So I need to combine 4x and 2x, which will give me 6x. I'm going to drop down the rest of my problem, the negative 6 or the minus 6, and the equals 30. I now have a simple two-step equation. I'm working backwards of PEMDAS. So I'm going to add or subtract first. So I'm going to be adding 6 to both sides. And I end up with 6x equals 36. Divide both sides by 6. And x equals 6. That was part A's answer. It said find the value of x. So x equals 6. Now to find the value of IJ, I was told equals 2x. So I'm going to take what x equals, take out the x and replace it with a 6. So I'll do 2 times 6, and IJ equals 12. Same thing for JK. JK equals 4x minus 6. Again, replace the x with 6. Multiply. Subtract. And JK equals 18. Now, one way you could double check your answer, remember that IJ plus JK should equal 30. So you could quickly add 12 plus 18. This was IJ, this was JK, and it should give you the length of IK, which it does. So it's a little way to check your answers by plugging it back in and making sure that it adds up to 30. And that is it for section 2's notes.